I am unable to access external websites. Therefore, I will provide a general overview of what one might expect to find in a typical hotel electrical equipment room, focusing on the technical aspects and safety considerations. The primary function of an electrical room in a hotel is to receive electrical power from the utility company and distribute it throughout the building to various loads, such as lighting, HVAC systems, elevators, guest rooms, kitchens, and other equipment. Firstly, the service entrance is where the utility company's power lines enter the building. This usually involves high-voltage cabling which is connected to a main switchboard or switchgear. Switchgear is a large assembly of electrical components including circuit breakers, switches, fuses, and protective relays used to control, protect, and isolate electrical equipment. The voltage at the service entrance can vary depending on the size and requirements of the hotel, but commonly it is something like 480 volts, 3-phase, or even higher in larger facilities. Secondly, transformers are essential components for stepping down the high voltage from the service entrance to low voltages suitable for distribution within the building. Common secondary voltages are 208/120 volts, 3-phase for general lighting and receptacle circuits, and 480/277 volts, 3-phase for larger loads like HVAC equipment and large motors. Transformers are typically oil-filled or dry type and require adequate ventilation to dissipate heat. Proper grounding and overcurrent protection are crucial for transformer safety and longevity. Thirdly, main distribution panels, or MDPs, are the central hubs for distributing power throughout the hotel. These panels contain multiple circuit breakers that feed subpanels located in various areas of the building. The MDP provides overcurrent protection for each circuit, preventing damage from overload or short-circuit conditions. The size and capacity of the MDP are determined by the total electrical load of the hotel. Sheffield load calculations are essential to ensure the MDP is adequately sized. Fourthly, subpanels are located throughout the hotel to distribute power to specific areas or equipment. Each subpanel receives power from the MDP and contains circuit breakers that feed individual circuits. Subpanels simplify wiring and provide localized overcurrent protection. The number and location of subpanels depend on the layout and electrical demands of the building. Fifthly, emergency power systems are critical for maintaining essential services during a power outage. These systems typically include generators and automatic transfer switches, or ATS. Generators provide backup power to critical loads such as emergency lighting, fire alarm systems, elevators, and life support equipment. The ATS automatically switches the load from the utility power to the generator power when a power outage is detected. Regular testing and maintenance of the emergency power system are essential to ensure its reliability. Sixthly, power distribution units, or PDUs, are often used in data centers and other areas with sensitive electronic equipment. PDU provide condition power, surge protection, and power monitoring capabilities. They help to ensure the stable and reliable operation of electronic devices. Seventhly, variable frequency drives, or VFDs, are used to control the speed of motors in HVAC systems, pumps, and other equipment. VFD improve energy efficiency by allowing the motor speed to be adjusted to match the load requirements. They also reduce stress on mechanical equipment by providing soft starts and stops. Eighthly, lighting control systems are used to manage lighting levels and energy consumption throughout the hotel. These systems can include occupancy sensors, daylight harvesting controls, and dimming systems. They help to reduce energy waste and improve the comfort of guests and staff. Ninthly, grounding systems are essential for safety and proper equipment operation. A properly grounded system provides a low impedance path for fault currents to flow back to the source, allowing overcurrent devices to quickly trip and clear the fault. Grounding systems must comply with the National Electrical Code, or NEC, Article 250. Tenthly, surge protection devices, or SPDs, are used to protect sensitive electronic equipment from voltage surges caused by lightning, switching transients, and other disturbances. SPD diverts surge currents to ground, preventing damage to equipment. SPD should be installed at the service entrance and at subpanels throughout the building. The NEC, published by the National Fire Protection Association, or NFPA, provides comprehensive requirements for the safe installation and maintenance of electrical systems. Adherence to the NEC is essential for ensuring the safety of people and property. Local codes and regulations may also apply and should be consulted. Electrical rooms should be kept clean, dry, and well ventilated. Access should be restricted to qualified personnel only. Proper labeling of equipment and circuits is essential for safety and efficient maintenance. Regular inspections and maintenance are crucial for identifying and correcting potential problems before they lead to equipment failure or safety hazard. Personal protective equipment, or PPE, is essential for working on or near electrical equipment. This includes safety glasses, gloves, and insulated tools. Qualified personnel should be trained in safe work practices and lockout/tag-up procedures to prevent accidental energization of equipment. Arc flash is a dangerous phenomenon that can occur when electrical equipment is energized. Arc flash can cause severe burns, electrical shock, and even death. Arc flash hazard assessment should be performed to determine the potential arc flash hazard levels and the appropriate PPE requirement. Arc flash labels should be posted on equipment to warn personnel of the potential hazards. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. Circuit breakers can be reset after they trip, while fuses must be replaced. The proper selection of overcurrent protection devices is crucial for ensuring the safety and reliability of the electrical system. The interrupting rating of the overcurrent device must be sufficient for the available fault current at that location. Conductors are the wires that carry electrical current. The size and type of conductor must be appropriate for the load it is serving and the environmental conditions. Conductor ampacity is determined by the NEC tables, such as Table 310.15b16. Conductors must be properly insulated and protected from physical damage. Raceways, such as conduits and cable trays, are used to protect and support conductors. Raceways provide a physical barrier against damage and help to contain fires. The type of raceway must be appropriate for the environment and the type of conductors being used. Electrical boxes are used to enclose wiring connections and devices. Electrical boxes must be properly grounded and securely mounted. The size and type of electrical box must be appropriate for the number and size of conductors being used. Wiring devices, such as switches, receptacles, and lighting fixtures, must be listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, or all. Wiring devices must be properly installed and maintained to ensure safe and reliable operation. Electrical meters are used to measure the amount of electricity consumed by the hotel. The meter reading is used to calculate the monthly electricity bill. Regular meter readings can help to identify potential energy waste. Power quality is a measure of the stability and reliability of the electrical power supply. Poor power quality can cause equipment malfunctions, data loss, and other problems. Power quality monitoring equipment can be used to identify and correct power quality problems. Harmonics, voltage sags, and voltage swells are common power quality issues. Energy management systems are used to monitor and control energy consumption throughout the hotel. These systems can help to identify areas where energy can be saved and to implement energy-saving strategies. Energy management systems can also be used to track energy performance over time and to verify the effectiveness of energy-saving measures. Preventative maintenance is essential for ensuring the long-term reliability and safety of the electrical system. Preventative maintenance tasks include inspecting equipment, tightening connections, cleaning components, and testing devices. A well-planned preventative maintenance program can help to prevent equipment failures and to extend the life of the electrical system. Thermography, also known as infrared scanning, is a non-destructive testing method that can be used to identify hotspots in electrical equipment. Hotspots can indicate loose connections, overloaded circuits, or other problems. Thermography can be used to identify potential problems before they lead to equipment failure. Load calculations are used to determine the total electrical load of the hotel. Load calculations are essential for sizing the electrical service, distribution panels, and other equipment. The NEC provides detailed requirements for performing load calculations. Coordination studies are used to ensure that overcurrent protection devices are properly coordinated to minimize the extent of an outage in the event of a fault. Coordination studies help to prevent nuisance tripping of upstream circuit breakers. Short circuit studies are used to determine the available fault current at various points in the electrical system. Short circuit studies are essential for selecting overcurrent protection devices with adequate interrupting ratings. Ground fault protection is used to protect people and equipment from ground faults. Ground fault protection devices, such as ground fault circuit interrupters, or GFCIs, and ground fault equipment protection, or GFEP, are required by the NEC in certain locations. Electrical safety training is essential for all personnel who work on or near electrical equipment. Training should cover topics such as electrical hazards, safe work practices, and lockout/tagout procedures. Documentation is essential for maintaining a safe and reliable electrical system. Documentation should include as-built drawings, equipment specifications, maintenance records, and test reports. Commissioning is the process of verifying that the electrical system is installed and operating according to the design specifications. Commissioning should be performed before the hotel opens to ensure that the electrical system is safe and reliable. Decommissioning is the process of safely removing electrical equipment from service. Decommissioning should be performed by qualified personnel and in accordance with all applicable codes and regulations. Sustainability is an increasingly important consideration in the design and operation of electrical systems. Sustainable design practices can help to reduce energy consumption, minimize environmental impact, and improve the overall performance of the electrical system. Power factor correction is used to improve the efficiency of the electrical system. Power factor correction capacitors are used to reduce the reactive power demand and to improve the power factor. Demand response is a program that allows the hotel to reduce its electricity consumption during peak demand periods. Demand response can help to lower the hotel's electricity bill and to improve the reliability of the grid. Renewable energy sources, such as solar and wind, can be used to supplement the hotel's electricity supply. Renewable energy sources can help to reduce the hotel's carbon footprint and to lower its energy costs. Battery energy storage systems are used to store energy for later use. Battery energy storage systems can be used to provide backup power, to reduce peak demand, and to improve the reliability of the electrical system. Microgrids are localized energy grids that can operate independently from the main grid. Microgrids can provide a more reliable and resilient power supply for critical loads. Artificial intelligence and machine learning are increasingly being used to optimize the performance of electrical systems. These technologies can be used to predict equipment failures, to optimize energy consumption, and to improve the overall efficiency of the electrical system. The Internet of Things, or IoT, is connecting more and more electrical devices to the Internet. This allows for remote monitoring, control, and management of electrical systems. IoT devices can provide valuable data for optimizing the performance of the electrical system. Cybersecurity is an increasingly important consideration for electrical systems. Electrical systems are vulnerable to cyber attacks that can disrupt power supply and compromise data. Cybersecurity measures should be implemented to protect electrical systems from cyber threats. These considerations are critical for designing, maintaining, and operating electrical systems in hotels, ensuring safety, efficiency, and reliability.